Lesson 4.5, Seeing Through the Static. How do we identify correlations in data? The goals of this lesson are to give students experience interpreting real scientific data and to expose students to what real data from large human observational studies looks like. At the end of this lesson, students should be able to find and describe the meaning of a correlation in scientific data and explain why large population studies may result in unclear data. We'll achieve these goals by having students interpret graphs from real scientific data. To prepare for this lesson, you will need to review the key scientific concepts that are presented throughout the lesson. These include how to interpret correlations in data and types of bias, including selection bias, confounding variables, and information bias. You can review the scientific content in the background reading provided for you in the teacher primer, the teacher manual, and the student workbook. The teacher primer provides in-depth knowledge about the scientific content presented in this lesson. The teacher manual or lesson plan provides minute-by-minute explanation of the lesson structure, including instructions on how to manage the discussion and the activity. And the student workbook provides additional explanations for the students. You will need to print one activity worksheet per student. The key point of this lesson's do now is that we think of foods as either good or bad, depending on whether we consider them to be healthy or not. We'll get there by having a brief Socratic discussion with the students. You will ask students to call out foods that they think are either good or bad. For those bad foods, students should list expected consequences of eating those foods. Some of these are listed on slide 6. The key points of this lesson's activity are that scientific data from large human studies do not always produce clear results, and that observational studies like the Framingham Heart Study can be used to find correlations in data but can't find causation. We'll get there by having students make conclusions from graphs of real scientific data. Each student should be given an activity worksheet that includes 3 graphs of data from the Framingham Heart Study. These graphs are the age of cardiovascular disease against blood LDL concentrations, age of cardiovascular disease against blood HDL concentrations, and the age of cardiovascular disease against BMI. Note that the data depicted in the graphs are not corrected for anything, and it is real data. Students will answer 4 questions on the activity worksheet using the provided graphs. These questions are: how does the line on the graph help us find correlations? Describe the meaning of the data. What type of bias may weaken this data? And how would you investigate a causative link in this data? Design a study. The Framingham Heart Study is a long-term prospective study of the etiology of cardiovascular disease among free-living population of Framingham, Massachusetts. This was a landmark study because it was the first prospective study of cardiovascular disease and identified multiple risk factors for this disease, including blood cholesterol levels. The study began in 1948 with 5,209 subjects and is still going today. Participants have been examined biannually since the beginning of the study. You can review all this information in the activity worksheet answer key. It has everything organized just as your students will be organizing it. Additionally, the teacher primer and the teacher manual go over all the key scientific concepts. The key point of this lesson's wrap-up is that even though the trends in data don't look strong, they are still significant results. We'll get there by having a short discussion with the students. Students may be surprised that the correlations in data are not obvious. Because human observational data are so variable, seeing any trend in data is interesting and warrants further analysis. If you are comfortable in doing so, this is a good lesson to discuss statistics with your students, particularly correlation coefficients called R or R squared. Students sometimes struggle with this activity because the correlations in the data are not very strong, meaning the slopes of the lines are small, and students expect the data to produce more obvious results. Even so, the Framingham Heart Study is one of the primary studies used to correlate LDL, HDL, and BMI with cardiovascular disease. The data are not perfect and there is a lot of variability, but that's the point. In human observational studies, you will inherently see a lot of variability. At the end of this lesson, students should be able to find and describe the meaning of the correlations in scientific data and explain why large population studies may result in unclear data. Lesson 3.6 discusses the mechanism behind why HDL, LDL, and BMI are correlated with cardiovascular disease, namely atherosclerosis. Don't forget that if you have any questions, concerns, or feedback to let us know. You can contact any of the CTS team members and we'll be happy to help.